Hi, my name is Belinda Marion Kobsinje, and my research topic is leveraging explainable transformer models for informed financial decision making among women in Uganda. My supervisors are Dr. Nangovuma Margaret and Mr. Galiwango Marvin. This is the flow of my presentation. So it has been reported by FSD Uganda that there's high levels of financial illiteracy among women, which has resulted in poor financial decision-making or uninformed financial decision-making among women that has resulted into low adoption of fintech applications. This can be partly attributed to language barrier, as most fintech platforms use English in a society that is predominantly occupied by non-English speakers. And well, machine translation is a great solution to address language barrier. Unfortunately, there exist low resource languages, such as Luganda. Luganda is a low resource language, which means that there's hardly data sets specifically related to fintech that can be used for training the models to address this language barrier. And secondly, the resource-intensive nature of machine translation models makes it further difficult to adopt machine translation solutions. Therefore, the proposed solution seeks to develop, train, and evaluate explainable, efficient machine translation models, specifically trained on financial literacy materials in English and Luganda. And to address the limited training datasets, we plan to develop and publish an open source fintech dataset that can be leveraged by the fintech developer community. So some of the related works, firstly, need to note that this is really, it's quite new. There's hardly academic material that are focusing on machine translation and fintech knowledge material. So you see that most of the literature that we found was mostly focusing on optimizing transformer models for low resource languages. And for us, our objective as we're reviewing the literature review is how can we adapt some of the already existing solutions. So one paper, Optimizing Transformers for Low Resource Neural Machine Translation, looked at these following low resource languages. And for them, they focused on using hyperparameter optimization. And their models were transformer-based and transformer-big. They use this as the baseline models. And then the second paper, boosting the transformer with BART supervision in low resource machine translation. They also looked at these low resource translations. And for them, they wanted to solve the issue of complex transformer models versus small data sets. So for them, they chose to train the encoder and decoder separately. And they also used the same baseline models and plus a pre-trained BART transformer model. So for the problem statement, there exists high levels of financial illiteracy among women in Uganda, which has inhibited informed financial decision-making, resulting in low levels of fintech service adoption among women. And simultaneously, the low resource nature of languages such as Luganda, coupled with the resource-intensive nature associated with machine translation model, has impeded the widespread adoption of machine translation solutions, making it difficult to bridge or solve this issue of financial illiteracy. Therefore, the main objective is to develop, train, and evaluate resource-efficient transformer models to translate fintech knowledge material from English to Luganda and vice versa, using explainable machine translation techniques that can then be leveraged by the fintech application providers for financial knowledge dissemination. For the specific objectives, we will create a parallel text corpus containing 4,000 sentence pairs in English Luganda on this fintech knowledge material. Then secondly, we create and train context-aware transform models. And third, our second objective is to inspect the context awareness of the transformer models using explainable techniques. So for the research questions, one of them was, how can domain adaptation techniques like transfer learning be used to minimize the data needs for training English to Uganda financial literacy translation models? How does incorporating domain-specific knowledge and financial terminology into the model training process affect translation accuracy and fluency? And third is, how can explainable AI methods be used to address and deal with potential biases in the translation output? So for the research contributions, we plan to build an open source high quality English Luganda dataset of 4,000 sentence pairs that is targeting the fintech domain in the Ugandan audience. And then we adapt the existing transformer models, that is BAT and GPT models, for specific challenges of translating financial literacy content between English and Luganda. And third is we enhance fintech app developer trust and transparency in machine translation for financial applications by incorporating explainable AI techniques. So our methodology is a two-phase methodology, where in the first phase, we are curating the data set, collecting the data set and cleaning it, pre-processing the data set to generate a high-quality data set. And then in the modeling phase is where we carry out fine-tuning of the transformer model to generate translations, which are then further evaluated using explainable AI techniques. And we use hyperparameter and parameter fine-tuning to optimize the transformer models. So we use a parallel text corpus, again, which contains 4,000 sentence pairs in English and Uganda, based on the topic of saving money. And the data sources are websites, social media posts of fintechs. So some of the fintechs we'll be looking at is Zeno and Passbank, which are both have saving products, and they usually have content based on saving, as you can see. So for the model selection, we use the BAT and GPT transformer models. And for the explainable AI techniques, we use attention visualization. What this one does is that it tries to understand whether the transformer models are looking at a broader context of the sentences, or they're just focusing on specific parts of the sentences, like which parts of the sentences are attributed to the translations. Is it just specific words, or are they looking at a broader context? Feature importance measures is also still similar to attention visualization. Again, it's looking at, is the model looking at the whole context, or is just looking at specific words? And lastly, we also use sharp and line, because these ones are commonly used by other researchers. Third, we use parameter and hyperparameter tuning to optimize the model. And then for evaluation, we use bilingual evaluation score, and accuracy, precision, recall, and the F1 score. And these are references. Thank you so much for your attention.